Hello, class. This will be the exam 3 review, which is it's going to open on March 30th, and then normally it would be due by the Sunday of next week. What is that? I think the 5th. But with next week being Easter holidays, then this test is going to get extended through the following Wednesday, April 8th. So first thing I want to do, well, as with the first two test reviews, the main thing I'll be doing is looking at the full review in Math Lab. We're not going to work every single problem. We'll focus a little bit more on making sure we can get them started. But before I do that, I do have the exam guide that is posted in Blackboard. So let's walk through that right quick, and then we'll get into a little bit more on the test. Okay. Yeah, so there are the dates, as I mentioned. Now, don't forget that there is no retest for this exam or exam 4. There wasn't supposed to be a retest for exam 2 either, but I did allow that because I still feel like that week that we had all that bad weather kind of still threw everybody off. But now we're back to schedule. So for those of you that have been relying on the retest, which is not necessarily a bad thing, but um, it's not something that you often get in college classes, particularly the higher level we go up. So this is why I have all those quizzes in there. So you can, be using those skill check quizzes, particularly the mini review, as sort of like your first attempt. And so that way, by the time you get to the test, it feels like a retest. That's why those quizzes are there. And for any of you that normally test on campus, be aware that the whole campus is closed, so no art on Thursday or Friday, April 3rd or 4th, which again is one of the reasons why this test is extended out through Wednesday the 8th. All right, so what is on this test? If it feels like this test comes up quick, is because there's really only 3 primary sections. So even though there's a lot packed in those sections, there are only 3 sections. There are 14 questions on the test, but as you've seen in the homework, then there are a lot of multi-step questions. So, if you broke it down by number of questions, there's, I don't know, maybe 30 at least. So, but they all are, many of these questions are 2 or 3 or 4 parts to them. Since we did have 3 sections, there are, each section is about a third of the exam. The 5152 is a little bit bigger, but for the most part, it's about 4-3 is a third, 5152 is about a third, 553 is about a third. And so don't forget that from test 2, the domain and range, the X and Y intercepts, transformations, those are all fair game on anything in this unit. Okay, so that is part of what you still need to, that carries over, that's still testable content. For this exam, as always, you have extra paper for work. And by the way, there are still some people who are not sending me their work when the test is done. Since you can't retest, you probably really want those chances for partial or extra credit, however you want to think of it. So please make sure when you write all your work out and then send it to me and you're done. And on this, this is definitely a visual content. And so you are allowed your graphing calculator if you have one, or the Desmos graphing app. For those of you that are coming to campus and testing in ARC, you can still bring up Desmos on your computer, even if you're taking a paper test. So that's not an issue. The one thing I don't know is I think I have HonorLock figured out how to let you access Desmos, because normally HonorLock doesn't let you open up a different website. But nobody came back to me on test 2 and let me know if they could actually access Desmos while they were taking the test. So I had to just guess that I've got it set up right. So there's that. Yeah. All right. So what is this test going to cover? So 4-3 parabolas. And so you have to be able to solve for the vertex. And that is like every single quadratic function problem, unless it's specifically asked for like x and y intercepts, every other problem you have to know the vertex. And also, to a lesser degree, the upward or downward, that's also important. But that's like a quick check. If A is positive, it's upward. If A is negative, it's downward. But you got to know how to find your vertices. Okay, if you can't find your vertices, using what, either look at it and see where the vertex is, or do the negative b over 2a part, then you're going to struggle with 4.3. Yeah. And then there are multiple things with 4.3 they could ask. You're going to have to graph them. And so either by matching or making sure you know how to use your math lab tools. You're going to have to find x and y intercepts possibly. You have to talk about max or mins, and transformations and domain and range. So all that's fair game. Okay, so that's the first third of the test. Second third of the test, or maybe closer to 40%, is the graphing polynomials. And remember, the only difference between 5.1 and 5.2 is 5.2 is where the longer multi-step problems really come into play. There are a few of those in 5.1, but most of those are reserved for 5.2. So the main thing on there is with graphing polynomials is you have to know the end behavior. Is it upward, downward, is it upward or downward parabola? Is it upward, downward S shape? Okay, that's core to this. And then the other half is being able to find all your zeros and their multiplicity difference. So if the end behavior is what happens to the far left and to the far right of the graph. The zeros and the multiplicity, that's what happens in the middle of the graph. Okay, so if you can't do those two things, then again, you're going to struggle with those problems. And then for the rational functions, the core is can you find the vertical asymptotes and the horizontal asymptotes if they exist. Everything kind of focuses around those two parts of the graph. All right. So that is big picture, like the core standards of what you're looking for exam 3. All right, so let's get into the full review quiz. And like I said, we're not going to do every single problem because there's like 50 problems in there. But we're going to make sure that we know how to at least start some of these problems and just get a general idea of what it looks like. Remember, if you're using this as a study, you don't have to finish it all at once. You can just X out of it and then come back to it later. I didn't share properly. Let me. There we go. All right. So I always like to try to start off the test if I can with a relatively basic question. So here is what is the graph of x squared plus 4? What does that look like? It's a matching question. All right. So there's a couple of ways you can do this. You can either think of this as x squared being transformed, or you can think of it as a vertex problem and to figure out where the vertex is. Like for me, I look at this, especially since it's matching, I think of this as a transformation problem because, it's x squared plus 4. What does that plus 4 do? It moves the graph up 4. So A is moved to the left, B is moved up, C is moved right, D is moved down. So if there was 2 of them that were moved up, then I'd have to be a little bit more careful. But that one's been moved, the only one that's been moved up, so it has to be B. Okay. So a lot of times with these matching questions, whether it's 4.3 or 5.1 or anything in Unit 3, is if you know the basic curve and you can do transformations, then that gets you a lot. Okay, so like this one, negative x squared minus 4. Okay. So what is, and again, if you think of this in transformations, what does that negative out in front of the x squared do? That's a vertical flip. So now we're looking for a downward parabola. That eliminates half of them automatically. And what does that minus 4 do? Well, it's not inside parentheses, so it's still vertical, so it's down 4. So I want a vertical flip, move down 4. So it looks like it has to be A. See, D is a downward, but it's moved up. F is a downward parabola, but it's moved left. And H is a downward parabola. It's been moved right. Okay. So all the upward parabolas, you should be able to eliminate immediately because of that negative for the x squared. All right, so that is, how you're going to start the test is just, can you do the, basic graphs with transformations? Okay, so let's walk through this one. So we need the vertex axis symmetry to remember whether it's concave up, concave down, or, the language I tend to use was open up or open down. The concavity language, that's more what you would use in calculus, but it's still, concave up means it opens upward, concave down means open down. And then we need to graph it. So how do we do this? F of x is x minus 2 squared minus 4. All right, so let's do all the work on paper, and then we'll back up and do it on MATLAB. All right, so anytime you're dealing with this, parabolas, you always need the vertex. Okay, and that's even what it says first is find the vertex. All right, so is this the form that you can look at and see the vertex, or do we have to do the negative b over 2a process? Well, we got the parentheses. There's not an x squared and an x, so this is, you should be able to look at it and see. And so, remember to change the sign on the x part and then keep the sign on the y part. So that would be a positive 2, negative 4. So there's a vertex. The axis of symmetry. Well, remember that axis of symmetry is that line that goes through the middle of the parabola that if you fold it, it lies on top of itself. It's a vertical line. So if you forget the x equals, you will get it counted wrong. Because if you just give me the x value of 2, that's not, what is that on the graph? 2 is nothing. It's not a point, or anything. So you need that x equals to get a vertical line. Okay. Next question, is it concave up or concave down? So how do we figure that out? Well, that is always by the a value, which is always in front of the x squared term or in front of the parentheses. A is positive 1. So it's a positive, so it's an upward parabola. There is no vertical flip. And then C, it says graph it. Now, if we're doing this by hand, and we know the vertex is at 2, negative 4. We know it is an upward parabola, so it's going to look something like this. Okay. So I can do a quick sketch by hand and have a general idea, but we need more detail. And so remember, in MATLAB, we need 2 points. So the first point always has to be the vertex. Okay. And so the vertex we said was at 2, negative 4. Now we need a second point. Okay. And so with that second point, it can pretty much be anything. I have 2 thoughts on this. One is 0 is normally a nice number to plug in, or you could always go to the vertex and go like 1 to the left or 1 to the right. So since the x of the vertex is at 2, then you can also do like x equals 1 or x equals 3. If you get too far away from the vertex, then your y values may be off the chart. But there's always going to be a y-intercept, but even the y-intercept might be off the chart. But since 0 is a nice number to do arithmetic with, I tend to, use that, start that as my second point. Then if it's off the chart, then I'll go back and, then I'd probably do like 1. So I plug that into the original function. So then it just comes down to arithmetic. The parentheses are important, so remember that is negative 2 being squared. 4 minus 4, so that's 0. So now I can adjust my graph accordingly. All right, so that's how I would do all of this, because this one, some of the multi-part problems, though, you have to like answer A before it'll say what's part B, and then you have to answer B before part C will show up. This particular question was showing all of them. So when it's that case, I tend to do all of them at once first, before I go start putting in a math lab. All right, so the vertex is at 2, -4. Axis symmetry, if you don't put that x equals, MATLAB and I will both count that wrong, because it's not a vertical line without the x equals. But we said that's concave up because there's a positive in front of the x squared. Okay, and so now to graph it, you could click on the graph itself. For me, with these parabolas, I think clicking the click to enlarge is a little bit easier for me to use. Then you click on the parabola tool, and it even tells you at the top, click the graph to plot the vertex of your parabola. So it's telling you the vertex you need to plot first. So where was the vertex? 2, -4. So 2, -4, not +4. And remember to watch your coordinates. Right now I'm at 1, -4. So now I'm at 2, -4. Right now, and again, hopefully, he practices his homework, but once you get that vertex locked in, then, you can kind of, you see why you need the vertex first. And then the second point I found was at 0, 0. And there you go. Now remember, if you know or you think one of those points might be off, once you plot both of them and you get that yellow line, like let's say I think I'm worried about my vertex, and like when I clicked it, I don't know if you noticed, but it moved it when I clicked on it. It's now at 2, -3. Okay. So, but remember, you can go to edit coordinates and you can type it in exactly where you want. For some reason, they don't let you edit coordinates until you have both points. But don't forget about that edit coordinates thing. All right. So there is a basic parabola question. Same thing here. The big difference on this is that it has a negative out front, so that would be concave down. Okay, and so for the parabolas, there's always two versions of these. One, can you look at it and see the vertex, like we just did with number 3, or this is my number 5, you have to use a negative b over 2a process. Okay, so for this one, I'm just going to do the vertex on this one because all the rest of it, follows with what we just did. But let's make sure we can find the vertex. So f of x is x squared plus 4x minus 5. All right, so since we have both x squared and an x, that means to find the vertex, we have to get the x of the vertex, we got to do negative b over 2a. To get the y of the vertex, we have to take that and plug it back in. And in our function notation, that's f of negative b over 2a. Okay, so step 1, what is the x of the vertex? And as always, be careful your negatives, but these are both positive. Getting -4 over 2 times 1. So -4 over 2, which is -2. I know the x of my vertex is at -2. Okay. Yeah. And so, and I will say, I might have mentioned this in the video, but if you get a fraction at this point, it's not necessarily wrong, but I mean, most of the time they are going to be whole numbers for the x of the vertex. So if you get a fraction at this point, I would double check the arithmetic here just to make sure that you didn't make a mistake. And for step 2, now we're going to get the y. So we're going to plug in -2. We're going f of -2. And again, make sure you use parentheses anytime you're plugging in numbers, particularly negatives. So that's what -4 is 5, so that's -9. So there is the vertex, -2, -9. And then it wanted the axis of symmetry. Well, axis of symmetry would be x equals -2. It wanted it upward or downward. It's upward because it's a positive x squared. Right? And then if you want a second point to graph it, first point is the vertex, -2, -9. And this form, it makes it really nice to plug in 0 because then, you're going to have 0 plus 0 minus 5. So when you plug in 0, y is -5. Right, so you don't have to do near as much arithmetic to find the y-intercept that you can use your second point in this form. Okay, and then you would go in MATLAB, do all that. Right. So here's a question. Let's say that you get to the test and for whatever reason you blank on this, you forget your negative b over 2a. All right, so if you can't get the vertex, it makes it pretty much impossible. Well, not fully impossible because you can do the concave up or down, but for the most of the rest of the problem, you can't do anything with the parabola if you don't know where the vertex is. So what do you do on the test on the parabola if you blank on it? This is what your graphing calculator Desmos app is for. Theoretically, you could do most of this test with those things, but again, it's try to use it as the backup, not the don't use it as a primary source to bypass the learning. And so like I said, as long as I got set up correctly, you should be able to go to the Desmos graphing calculator on the test. And so let's put this in. So we got x squared. So hopefully you've been practicing the graphing apps as you've been doing your homework. So you haven't, and then you get to the test and try to use it. It's probably not going to do you much good. Now we plug it in, and let's see the full parabola. I need to zoom out a little bit. And so there's our parabola. Where's the vertex? Come down here and notice that it puts highlights on the intercepts and the vertices kind of naturally. And right there, -2, -9, that is the vertex. What I get is the second point of 0, -5. Right there is my 0, -5. And you can see it's clearly an upward parabola. So don't forget about your graphing app. That's a good backup for this test. And if you're like if you want to show work, like and you're using the graphing app, then just like on your paper, say I use the graphing app and then like do a quick sketch or something like that. Yeah. All right. Let's go back to the quiz. All right. But again, that's a pretty straightforward question for a parabola. Now this says without graphing, I'm not going to know if you graph it first, but determine without graphing if the quadratic function has a maximum or minimum value and then find the value. So how do you know if something has a max or min? So the very first thing that I do is this an upward parabola or downward parabola? Because that tells you whether or not it has a max or min. Well, that negative in front of the x squared tells you it is a downward parabola. And so if you have a downward parabola, does it have a max or a min? Well, downward parabolas have that upper peak, so they have a maximum. Now, when it says the value, what is the value of the maximum? That's the y of the vertex. And so all maximum problems are vertex problems. Okay. This has both an x squared and an x, so you have to do the negative b over 2a process that we just did on number 5. And then once you find the y of the vertex, that's the value they're looking for. Okay, so those are, that's pretty straightforward with the parabola if you've been doing your work. Notice that we did not talk about the quadratic format at all with parabolas. That's a fairly common mistake on this test is quadratic formula is something that you've used a fair amount in your algebra career probably. And so sometimes people revert back to quadratic formula on vertices. But remember, to find the vertex, it's either you look at it and see because it's in that one form, or you gotta do negative b over 2a for the x. Do not use the quadratic formula to find vertices. Use the quadratic formula to find x-intercepts. Okay. All right. So polynomial functions. All right. So again, we're going to start as a little warm up here. So what is the degree? Well, first of all, it is a polynomial because we're not taking like square roots of x or absolute value of x, or we're not dividing by x. So this is our typical parabola. Now it's not in descending order, so you have to be careful, but it is a polynomial. So what's the degree? Well, it's not in factored form, so the degree is just the highest exponent, so that would be 5. All right. Yep, so there we go. Then write this. What does it mean by standard form? Standard form means make sure it's in it's like it is if it's factored, you got to like FOIL it out. This is not in descending order, so standard form for this would be x to the 5th plus 3x. That's what they mean by standard form in this case, is put it in descending order. With the leading term, well, the leading term is x to the 5th. Because the term, it says term, just the whole thing. And then the constant, well, there is no constant. So what do they want here? Oh, I remember now. I took this was in the homework. I actually took this one off the test because I didn't like, because there is no constant here. So there should be it's two variable terms. So I don't know what they want. Constant 0. So I took this question off the test due to that kind of ambiguity of this. But you still need to be able to look at it, see if it's a polynomial or not, know what the degree is, and know what the leading coefficient. That's what you really need to do. So I would say ignore the this version of the question. So like again here, just is this a polynomial function? No, because we're dividing by x. And actually, and again, this is that one I took off because it wants to know the power. The way they word this is poorly worded. So I found a more basic version of this question for the test. Okay. So that's sort of the warm up. Yeah, I need to update the quiz, but just can you identify what's a polynomial and do you know the degree and the leading coefficient? Yeah. All right, so just like with parabolas, we're going to do transformations with these polynomials. And so use the transformation to graph y of y equals x to the 4th to graph the function x plus 3 to the 4th. So what does x to the 4th look like? Well, this is a different way to ask you the end behavior. Okay, so one thing on the end behavior is you need to be able to recognize, is it an upward or downward parabola, or is it an upward or downward S shape? Okay, and how do you know that? First of all, go to the degree. So the degree here is 4, because there's only, there's not multiple. If there were multiple factors, then we'd have to like add them together, and they would do that in a different question. So the degree is 4, which is even, so it's going to be a parabola shape. If you go out front, it's a positive 1, so it's an upward parabola. Okay, so and if you notice, all of these here are upward parabolas. So that's why, so this is basically acting like x squared. So what you need to do, what does that plus 3 do to the graph? Well, is that horizontal or vertical? Well, it's inside, so it's horizontal. So what does plus 3 do horizontally? That moves, remember horizontal is backwards, so it moves it to the left 3. And then how do you know which one of these is the right one? That one looks like it's moved left. That one's definitely moved down. That one's definitely moved up. D is definitely moved right. So A is the only one that's been moved left 3. But this is where for the transformations of polynomial functions, if it's an even degree, then it's going to be a parabola like x squared. If it's an odd degree, 5, 7, whatever, it's going to act like x cubed and be in an S shape. Okay, like this one. This is x to the 5th, so that's an odd degree, so that's going to be an S shape. And then what does that minus 7 do? Well, it's not inside the parentheses, so it's not horizontal. It's outside, so it's vertical. And so that's going to do what we expect. So that goes down 7. So when so there's our S shapes. And so notice that they kind of put the axes right at the edge on all these. It makes it a little bit harder to read. I always like to make my axes a little bit more obvious, but that's why they got the arrows on the end. So we're looking for something that's been moved down 7. Well, there's 0, 0. So A has been moved right. B has been moved left. C has been moved up. And then D, because there's the axis, has been moved down. Okay, so it has to be D. All right. So the transformation stuff of the polynomials works the same as we're used to. It's just remember that even degree polynomials look like x squared, odd degrees act like x cubed. Okay, well, this is 2 transformations. So the -8 moves it right 8 and up 5. And like for your work on the test, write that down. Like whatever you think the transformation is, write it down. So that way I can see, like, did you just pick the wrong graph or did you have the wrong transformation? That gives me a chance, that gives me some insight in case you missed it. So right 8 up 5. Okay, so A has been moved up, but that looks like left. B has been moved down, so it's not that. C, remember all these start at 0, 0, so that one definitely looks, it's kind of hard to see the S shape, but there's a little bit there, but that's definitely been moved up and to the right, whereas D has been moved down and to the left. Has to be C. All right. So this is one, like I said, I feel like this is a little out of order, but that's kind of where it ended up in the homework. So write the form of polynomial whose zeros and degree are given. And the reason I kind of wish this was a little bit later, because I kind of feel like we should talk about what the zeros mean first before we give you this problem. Basically, we're going backwards. Right? Normally we give you the polynomial and you find the zeros. Now we're giving you the zeros and what the polynomial. So how do you do that? This is one of the things we didn't do often. So sometimes it gets missed a little bit more because it's not as a big of emphasis, but it's also less points. And so the way that you do this, remember, we're basically saying x equals -3. We're saying x equals 3. We're saying x equals 8. We're saying those are the x-intercepts. So that's when we had it like what y is equal to 0 and like salt. So the way that you get the polynomial from this is basically you have to go backwards and make this equal to 0. So you would add 3 to both sides. So x plus 3 is equal to 0. Here we need to move it over. So then we have x minus 3 equals 0. Here we're going to subtract 8 from both sides. So x minus 8 equals 0. And so the polynomial, and so the degree is 3 because there's 3 zeros, so we don't have to like have like 2 of these. Like if the degree was 4, one of these would have to show up twice. Okay, so we're not going to get that messy. So the polynomial, once you set these equal to 0, you have your factors. So you have x plus 3, x minus 3, x minus 8. That's all we're looking for. Now it does say simplify, which would kind of imply that you have to FOIL it out. I think they actually accept it, not FOILed out, and I would, don't FOIL this out. This is the answer I'm looking for. If you give me this, you get full credit. Okay. But when they give you the zeros, what you have to remember is that that's telling you x is equal to -3, and where did that come from? Is at some point we had a factor of x plus 3 that, and so on. Okay. This is, in chapter 2 with all the lines, remember how you had to write the equation of the lines where we give you like a point and the slope and basically going backwards? This is the equivalent of that for in polynomials. But like I said, expect no more than one of those. That's it's something we covered, but it's not something that we spent much time on we had bigger fish to fry. All right. So now we're starting to get into more of the 5.2 version of this because now they're going to, well, actually, no, this is just the zeros and multiplicity. So we're not quite to 5.2 yet. All right, so for the given polynomial function, we need each zero and its multiplicity, determine whether the graph crosses or touches the x-axis at each x-intercept, determine the maximum number of turning points, and then determine the end behavior. All right, and notice that we don't have you graph it. So this is not the full length version of this problem quite yet. This one definitely focuses a little bit more on the zeros and the multiplicity. This is my number 15. The f of x equals -3 x minus 2 x plus 3 squared. So the first thing is they want their zeros and the multiplicity. And the next one they want is the behavior. So I'm used to doing this as a table form. I'd recommend like doing this in table form first, and then translating your answers over into MATLAB. So let's see how we answer this question. All right, so I'm gonna do a table for zero, multiplicity, and the behavior. All right, so how do we find the zeros? Well, remember zeros are x-intercepts, so y is equal to 0, f of x equals 0. So we're just saying 0 is equal to -3 times x minus 2 times x plus 3 squared. So to get the zeros, we need all the factors that have x in them, set them equal to 0, and solve. We don't need to worry about that -3 factor because there's no x. And so since there's no x, it doesn't give us an x-intercept. We just need those two. And so what we do is x minus 2 equal to 0 over here. Now ignore the exponent for now because that's going to be part of the multiplicity. The 0 itself just comes from the factor. We get x equals 2 and x equals -3. So those are our zeros. Now, sometimes they don't care about the order, sometimes they do. I recommend just always assuming they want them in order from left to right. That way you don't have to worry about any issues with MATLAB. If you get them out of order when they want them in order, I would still give you credit as long as you get all this right. But start from left to right. So let's start with -3 first and then do 2. Again, we ignore that -3 because if you set -3 equal to 0, that's never going to equal 0. So there's no answer from that. All right. So what is the multiplicity of the 0 of -3? Well, where did the -3 come from? It came from that factor x plus 3. The multiplicity comes from the exponent. Okay, so that's multiplicity of 2. And then the x equals 2 came from this, where there's basically 1. So the multiplicity is 1. Now what's the behavior? Well, multiplicity being even or odd is what matters. If the multiplicity is even, it acts like a little parabola. So that's either going to touch, what do they use, touch or bounce? So it touches. Then it turns around and bounces. If it's odd, it acts like a little S shape at the intercept, and so then it's going to cross the x-axis. So even multiplicities tells behavior touches right at the x-intercept. Odd multiplicity tells us it crosses. Now let's go ahead and answer all these before on paper before we go to math lab. So C is the maximum number of turning points. Now, one of the reasons this gets asked a fair amount is this is something that in calculus would be a much bigger deal. For us, all you need to know is turning points are your maxes and mins. Right? And so what's the maximum number? What you need to know is it's the degree minus 1. So what is the degree of this polynomial function? So this is where you have to be careful because a lot of times I hear people say 2 because we've kind of conditioned you to look for the biggest exponent. But remember, if it's in factored form, you have to add up all the exponents. It's not just the largest one, it's all of them. So here the degree will be 3. And so when we talk about the maximum number of turning points, the degree would be 3 minus 1 or 2. So you could have like 1 max and 1 min. But you don't need to know if they're max or min, you just need to know that there's 2 of them at most. And then the end behavior. Well, let's do it with our little upward downward S or upward down parabola, and then we'll see how MATLAB wants it. All right, so what do we know? Well, we know the degree is 3, so that gives us an S shape. So there's an upward S shape or downward S shape. Well, we have a -3, so that's our leading coefficient. This is a downward S shape. Now, MATLAB is going to want a different answer, so let's go back in and answer all this in MATLAB. All right, so the real zeros, and notice it didn't say anything about the choice. Normally the order is when we start talking about the multiplicities. But again, doesn't hurt to get in the habit of going just from left to right. We have -3 and 2, or our zeros. Now the larger, this is where you have to be careful because they're not always consistent because different people code these problems. The larger zero, that's the one on the right. So the one on the right was 2. We said the multiplicity was 1. That's why I like having this chart before I jump into MATLAB because I've got my zeros and their multiplicity written right there. Multiplicity of the smaller zeros, that's the one on the left. So that was the -3. And multiplicity of that one was 2. Okay, so the graph, does it touch or cross at the larger x-intercept? That was at the 2. The multiplicity is odd, so it crosses. And then the smaller x-intercept was -3. Multiplicity is even, so that touches and turns around. So do you see the benefit of doing that chart? Yep. This chart here. If you do that before you put the answers in MATLAB, it's all right there for you to find. You don't have to go back and like figure it out again. It's all written right down there for you. So I highly recommend that when you're doing zeros and multiplicity, do this chart. Okay. Maximum number of turning points, that was the degree -1. We said the degree was 3, so this is 2. Okay. Now, when it said determine end behavior, find the power function. This is something that popped up in the homework. And so what you need is, we know the degree is 3, so we're going to have an x cubed in there. But you also need the leading coefficient. So the leading coefficient is at -3. So put that leading, if there's anything other there than like a 1, make sure you put that in there for full credit. Right. And then this is a degree 3, so do x cubed. Yeah. If this was a degree 5, then put x to the 5th. If it was degree 4, put x to the 4th, and so on. So we need the leading coefficient, and we basically need the degree. That's how they want that answer. Whereas if you put that wrong in your paper or in math lab, but like on your paper, you gave me like the downward S, then that's going to get you partial credit. Okay. So how about this? Am I showing the right graph? I'll make sure it's shared. Okay. So construct the polynomial function that might have the given graph. Oh, this was sort of like we did this before where they gave us like -3, +3, and -8. We had to work backwards. And so this is sort of the same idea. So how do which of this A, B, and C is correct? Well, first of all, look at the intercepts. There's an intercept at 0, an intercept at -4, and an intercept at -5. What does that mean? So, okay, so from the graph, those are the intercepts. So how do we turn that into those other choices? Well, we need the binomial factor, so basically we've got to go backwards. So, well, that's already equal to 0, so that's just x. This is, so on this one, we need to add 4 to both sides. So that comes from x plus 4 equals 0. So x plus 4 is one of our factors. And then for this one, we got to add 5 to both sides. So x plus 5 is our third factor. So we need an x plus 4, and x plus 5. Okay. All right. So it can't be A or B because those are both -4 and -5. So that would be if the intercept is over here to the right with a +4 and +5, then we change the signs and the factors. So what's the difference between C and D? Well, C has x squared and D has x. And so that's where x was equal to 0. So if you look at x equals 0, what's happening on the graph? It's crossing. So if it's crossing, is the multiplicity odd or is the multiplicity even? Well, crossing means odd multiplicity. So we need it can't be C because that's an even multiplicity. Right? So that's a multiplicity of 1, so it has to be D. To get an x squared, it'd have to like come up to 0 and then like touch it and like turn around and go back down. So that's an alternate way to ask the other question. Yeah, so just like this one. So we have x-intercepts at -2, -1, and +1. So the factor forms, basically the signs are going to change. So we need an x plus 2, an x plus 1, and x minus 1. All right. So I'm looking at x plus 2. They all have x plus 2, so that doesn't help. They all have x plus 1, x minus 1. So this really kind of comes down to two things. One is some of these have +1/2, some of them have -1/2. Now notice they all have a 1/2. So realistically, we can ignore the 1/2. Basically what that does is that kind of makes it wider and narrower, but they all have the 1/2. So what's important is it a positive or a negative? Well, is this a parabola shape or is this an S shape? Well, they're going in the same direction, so this is a parabola, but if you notice, it's a downward parabola, so we need a -1/2. Okay, so we can eliminate A and E because those have positive, so those would have been upward, like flipped. All right, so the difference in all of C, B, D, and F is, you know, when they have x squared or are not. And so on -2, it crosses. On -1, it bounces or touches and turns around. +1, it goes through. So what that tells me is the only one that should have a 2 exponent is at -1, which is the x plus 1. So that would be C. Okay. So that has a 1 multiplicity, it crosses. That has an even multiplicity, so it touches and turns around. that has an odd multiplicity of 1, so it crosses. This is a messier version of 16. For this level of question, I would, if this was going to be a test question, I would do 16 rather than 17 because those 1/2s tend to throw people. And this was just a little bit like for what we're doing, 16 or where was it? 16 or 13 would be, you would get one of those two. All right. So then you get into parts A through E. So this is the 5.2 version of this problem. So it wants to know the end behavior. It wants to know the X and Y intercepts. It needs to know the zeros and their multiplicity, maximum number of turning points, and then we need to graph it. Okay. So let's do one of these because, like I said, you're definitely going to have at least one, probably not two, because there's only 14 core questions on the test. So this is what is this, number 18? And f of x is 9x minus x cubed. All right, so A is the end behavior. Yeah. All right, so what is the end behavior here? Well, first of all, what's the degree? Well, it's not in descending order, so gotta be a little careful. The degree is 3, so it's acting like x cubed, right? And then it's a negative. So for us, we would say that's a downward S shape. Odd degree, negative leading coefficient. The way they want it is put your leading coefficient, which is negative, and then it's going to act like x cubed, so put in x cubed. So they're still not asking you what the end behavior is. They're identifying like, do you know the important information that tells us the end behavior? Right. So I wish they would kind of word it a little bit different. Okay, now find x and y intercepts. Okay. Definitely have to go to the paper for this one. All right. So x-intercept means y is equal to 0, or in this case, f of x is equal to 0. Okay. Now, this one's a little bit messier because you actually have to factor it. It's not already in factored form. So to factor this, like the very first thing I'd look at when I see this is not in descending order. Okay. So put it in descending order to make your factoring a little bit more straightforward. All right, so how do you factor this? Well, there's a GCF of x. Okay. Now, the other thing, the fact that since it's not, now that we got in descending order, since the leading coefficient is negative, factor out a negative x, not just an x, but a negative x. So if we divide both of those things by negative x, we get x squared and then minus 9. Now, that can still be factored because that's a difference of squares. So x plus 3, x minus 3. If you didn't factor out the negative, you would have had 9 minus x squared, and you'd have 3 plus x and 3 minus x. Right, so in the end, you'd get the same answers. It would just look a little weird because we're used to having the x first. That's what it looked like. If you would have kept it in this form, there's that GCF of x that you get factored out, and then you would have had 9 minus x squared. And then 9 minus x squared is still a difference of squares. That's 3 and 3, x and x. But you're going to get the same answers if you solve. And so then we have negative x is equal to 0, x plus 3 is equal to 0, x minus 3 is equal to 0. So solve those, we get x equals 0, x equals negative 3, x equals positive 3. Now, since they are talking about this, remember x-intercepts are zeros. So let's go ahead and do our chart. Another room. Sure. We don't need it immediately, but we will need it at some point in the problem. So since we found the zeros right now, let's go ahead and do this information. We have 3 of them. Remember, go from left to right, just to cover your bases. So we're going to start at negative 3, then to 0, then to 3. So what are the multiplicities on here? We go back to the factored form. Notice you have no exponents, so they're all 1s. And then what's the behavior? Well, they're all odd, so they all cross at the x-ends. Okay. All right. So all they want for part B right now is the x-intercepts, which are the zeros. But now we have this. We don't have to go back and later and like refigure out all of this. Okay. It's one of the things I do with multi-step problems is try not to redo the work. Okay. So those are our x-intercepts. And let's go ahead and do the y-intercept. So the y-intercept, plug in x equals 0. So our original function is 9 times x, so 9 times 0 minus x cubed, so 0 cubed. Well, that's 0, that's 0, so it's 0. There is our y-intercept, which just also happens to be an x-intercept. Okay, what do they want next? Determine the zeros of the function and their multiplicity. Use this information to determine where the graph crosses or touches. Done. Okay. That's part C. Determine the maximum number of turning points. So on this, you just have to remember that that is the degree minus 1. And the way that you get the degree is, if it was in factored form, you have to add these up. That would be the degree. But remember, this was not in factored form. That was a normal polynomial form. So we know the degree is 3. So that would be maximum turning points would be 3 minus 1 is 2. And then we're going to graph it. Okay. So let's put all this information into MATLAB and see how we're going to graph it. Okay. So we already talked about the end behavior. It's going to act like negative x cubed. X-intercepts we saw were, now notice it didn't say anything about the order, but again, I think it's always good for these x-intercepts to put them in order. So negative 3, 0, and 3. The y-intercept, when we plugged in x equals 0, we got y equals 0. Okay. Now determine the zeros of the function and their multiplicity. So the zeros are the x-intercepts. Okay. So same answer, negative 3, 0, 3. Okay. Now for the multiplicity, the smallest 0, remember that's the one on the left. That's why I put them in order. So again, the way they ask this to me is always out of order. They want the multiplicity first, but let's start with the 0. So we're looking at x equals negative 3. The multiplicity, they said they were all 1 because we didn't have any exponents when we factored it. So the graph crosses at x equals negative 3. The middle zero was 0, so at x equals 0, it has a multiplicity of 1, because they all have multiplicity of 1 in this case. So it crosses. And then the largest zero is the one on the right, which is 3. It has a multiplicity of 1 again, because we didn't have any exponents on our factors. And so they all cross. Again, if you get these, like if your order is wrong on here, but you get the multiplicity and the behavior with the right intercept, then I will give you credit as long as you turn in work. If you don't turn in any work, and you get the order wrong, then you just lose the points. Because like I say, if you don't care enough to turn in your work for me to look at, then I'm not going to look at your task. And so there's a lot of times people lose easy points because they're not turning in the work. Right. Determine maximum number of turning points. That was the degree minus 1. The degree was 3. This is 2. And now we need to graph it. So how do we graph something that's x cubed? Right, well, now we need our cubic tool. Notice it says 4-point cubic tool when I hover over it. Okay. Now, unlike the vertex or the parabola where you have to do the vertex first, this is just the 4 points. So what do we know about our 4 points? Well, we know our x-intercepts are -3, 0, and 3. So the first thing I would do is plug in those intercepts. So we got -3, 0. Now notice that it's not highlighted on here, but you can see up in the upper right that I'm at -3. So there's -3, 0. Then my next intercept was at 0. And my third intercept was at -3, or sorry, +3. Now it looks like a horizontal line, but notice that we got to have a fourth point, okay? And so it would have been nice if the y-intercept had not also been 0, 0, because then we would have had a fourth point. But since the x and y-intercepts were overlapped, we need any fourth point. So here's what I would do is pick a number that's easy to work with. So let's go in and plug in 1. So here's what we're doing with the points. Yeah. So we need 4 points. So from our x-intercepts, we had -3, 0, we had 0, 0, and we had 3, 0. Okay. Those were our x-intercepts. Turned out this was also the y-intercept. Okay, so we need in this case, we need a fourth point. Okay. So let's just plug in x equals 1. Okay, because it's a nice number to plug in. It's between 0 and 1, so it shouldn't be too big. So we are doing 9 times 1 minus 1 cubed. We get 8. Okay, so just like with the parabola, you needed a vertex plus one other point. For the cubic, if you have 3 x-intercepts, then you need one other point. If you had like 2 x-intercepts, then you need 2 more points. So we did this with lines too. We were just taking x's, plug it in, figure out what the y is. Now when we go back to the chart, go to the graph. So 1, 8. So now I can do that fourth point. And again, I'm watching in the upper right on mine, or in the lower left if you're doing it with the other graphing tool. And so I'm at 1, 8, and so there is our polynomial function. And if you think any of those are wrong, click on them and you can edit your coordinates. So that's how you graph these in MATLAB. And then the other nice thing about this, again, let's say that you're worried that you're missing something with all these steps. Go to go back to Desmos. What do we have? We had 9x minus x cubed. All right. And sometimes you're gonna have to play with this graph. I'm not gonna explain that all over again now. Hopefully you've been working out the homework. So, but there's an x-intercept at -3, x-intercept at 0, 0, x-intercept at 3, 0. What do we say? 1, 8. So I try to click here where x equals 1. Now, notice I don't get exactly on it, but it's 1.01 and like 8.05. So that tells me that, oh, I got it right there. I would just like, I'm holding my mouse down and it's giving me points. Now this, but that's right there. I had it before now. Oh, there it is again. So, but that's how you can check this. And like there's your overall graph. What did you have in math lab? It looks a lot alike, right? So don't forget that you can go back and use the graphing app to back you up. All right, so that is 5.1 and 5.2. And so you're going to have some individual pieces with just what's the end behavior, where are your zeros and your intercepts, and then put it all together. And then we get in, once we start doing rational functions, then we start talking about domain, vertical asymptotes, horizontal asymptotes. Okay, so now we have to shift gears again. Because the rational functions, it's all about where are the vertical asymptotes and the horizontal asymptotes. And for the domain, remember domain and vertical asymptotes are the same. We find them the same way, but they're opposite sides of the coin. So for both the domain and vertical asymptote, step one is where do we divide by 0? And to figure out where we divide by 0, take the denominator, set it equal to 0, and solve. Which this one's nice because we don't have to factor because it's already factored, and don't FOIL it out because if you FOIL it out, then you're going to do the quadratic formula, factor it, and get right back to here. So since it's already factored, just set each factor equal to 0. So we get x equals 5 and x equals -4. So this is where, are we asking for domain? Are we asking for vertical asymptotes? So if it was a vertical asymptote, the vertical asymptotes are those vertical lines that occur where we divide by 0. So the vertical asymptote answer would be x equals 5, x equals -4. Okay. Because that's where we divide by 0. It's the vertical lines there. Remember, domain is going to be all real numbers except x equals 5 and -4. And so the way we answer that in interval notation, think about this on a number line. So we're looking at -4, we're looking at 5. We don't want -4, -5. So basically there's an open circle on those two because we don't want those, but everything else works. So if you're struggling with the domain on the rational functions, put them on a number line like this. And so what's the interval for that left part? Well, from -infinity to -4 in parentheses because we don't want the 4. We're not equal to -4. Now this is where MATLAB was wanting you to use the union. They didn't say put a comma between them. If you put a comma between them on the test, I will go ahead and give you credit for that because that's what we did back in test 2. But again, unfortunately, they're not always consistent on this, but the union is what they're expecting. And then we have the middle interval from -4 to 5. And then we have the interval from 5 to infinity. So remember, domain and vertical asymptotes both. You take the bottom, set it equal to 0, solve for x. If it's already factored, just set each factor equal to 0. If it's not factored, then you have to factor it and then go from there. Or you can do the quadratic that's squared. but the domain is going to be all real numbers except the answers we get. Vertical asymptotes are the answers that we get. Okay. So this is what they're looking for. Right. And if you're not for sure if you're doing the interval notation right, I mean, like this is where like showing your work and saying like all real numbers except 5 and -4 will get you a good part of partial credit. And this is obviously, because if you write it this way, then you know the concept. It's just you're not going to get full credit because you didn't do it in the preferred notation. So we have negative infinity to -4. And then for the union, they do have that button right there on the button palette. It's union, and then go from there. -4, 5, and then we got a third one, so we got to do another union. +5 to infinity. Okay, so that's the domain of a rational function. Where you divide by 0, domain is everything except those answers. Okay, so there's several different ways we can ask these rational function questions. So here we have f of x is 7x squared minus 2 over x squared. Graph the rational function using transformations. Use the final graph to find the domain and range, and then use the final graph to get any horizontal or vertical asymptotes. All right. Now, this one, the transformation is a bit complicated. Like if it was just like if that 7x squared minus 2 wasn't on top, or the 7x squared on top is what makes this messier, right? And so if you're not for sure of the transformations with the rational functions, start with the horizontal vertical asymptote. That's for these graphs, for these rational functions, those are the key to the graphs. It's sort of like for the parabola, you got to know where the vertex is. So let's ignore the transformation part of this and just find the horizontal and vertical asymptotes. And then we can see how to graph it from there. Okay. So let's work through this on paper. All right. So where do we get the vertical asymptotes? Where we divide by 0. So you take the denominator, set it equal to 0, solve for x. Well, what times itself gives you 0? Basically taking the square root of both sides. Yeah, I could give you a hard time on not forgetting the plus or minus, but plus or minus 0 is still just 0. So there is your vertical asymptote. So the only time we're going to divide by 0 is if x is 0. So we have one vertical asymptote. Okay. Now for the horizontal asymptote, that's where you have to compare the degree of the top with the degree of the bottom. And there were 3 cases. If the degree of the top is smaller, then it's always at y equals 0. Okay. But we're in case 2 because the degrees are equal. So when the degrees are equal, it's at y equals, and you take the coefficients. So 7 over 1 or y equals 7. If the degree of the top of the numerator is larger, that's when we have no horizontal asymptote. We have just a oblique asymptote. And you don't have to worry about what the oblique asymptote is. You just have to know that the top is larger. It's not horizontal, it's oblique. All right. So to get the graph, here's what I would do is I have a vertical asymptote x equals 0. So at x equals 0, do a dashed vertical line. There's your vertical asymptote. And then do the same for your horizontal asymptote. So y equals 7. In the horizontal asymptote. All right, so just based on that, let's see if we can figure out the graph. If not, then we're going to have to plug in like a point on either side of the vertical asymptote, and then that will tell us. But let's see what we can do just from this information alone. So when it's matching, sometimes you don't have to do all the work. Okay. All right. So looking at the choices, um, first thing I notice is A is up there at y equals 7, B is down there, so it can't be B, because that horizontal asymptote is probably -7, so it's not B, and it's not D, because those have the wrong horizontal asymptotes. Okay. Now, if you look at A and C, they both have a horizontal at y equals 0, or sorry, y equals 7. They both have a vertical asymptote. This one's kind of hard to see in A, because you don't get to see a lot of it, but you can kind of tell it's kind of symmetric about the y-axis. So that's x equals 0. So both C and A have the right asymptotes. They both have a horizontal at y equals 7. They both have a vertical at x equals 0. So how do we figure out if it's A or C? Okay. This is where I would go in and just plug in a number. And then I would go like just to the left or right of the asymptote. So let's plug in x equals 1. So I mean, and yes, I know this was originally a transformation problem, but like I said, that's if it was -2/x², then right there I could tell you that that minus is a vertical flip, and that would have been C, right? But we have that 7x², so that makes the transformation. I don't know why they did this as a transformation question, to be honest. But what we're doing, we're trying to figure out, is it up above this or below this? So let's plug in x equals 1. And the reason, again, the reason I'm choosing 1 is my vertical asymptote is at x equals 0, so I'm just going to the right. I could also do -1, but let's start with the +1. So we're going to do 7 times 1 squared minus 2 over 1 squared. I'm getting a +5. When I plug in x equal 1, I got +5. And so now, since we're matching, let's go back to choices. So we said it either had to be A or C because of the horizontal asymptote. But if we want 1, 5. So where is 1, 5? Well, these are counting by 2, so right there, and then we go up 5, still counting by 2s. So 1, 5 is about right there. So that's not on A. If you go over here to C and do 1, 5, then over 1, up 5. So that, it's kind of hard to tell exactly, but that clearly is close where this one is nowhere close. That would be like 1, I don't know what, 1, 9 maybe? But we got 1, 5, so it has to be C. Right. So like I said, it's for any of these matching, for the parabolas, start with the vertex, and if it's upward or downward, then if that doesn't give you enough information, pick an X, plug it in. Same way with the rational functions. Start with your horizontal vertical asymptote. If that doesn't give you information, plug in an X, find a point, and then you're generally good. Okay. All right, so so C is what we're referring to. So now that we have the picture, they're asking us the domain. So remember, the domain is all real numbers except where we divide by 0. Well, we said there's a vertical asymptote at x equals 0 because that's when we divide by 0. So that means the domain is all real numbers except 0. So we don't want 0. We're going to go from -infinity up to 0 and put a parentheses so we're not equaling 0. And then union 0 to infinity. So that is the domain is every number except 0. Because that's where we divide by 0, that's where the vertical asymptote is. Now for the range, Okay. Now the range, well, again, we have the graph. Remember, range is low to high. So how low does this graph go? Well, it goes down forever. So it's going to start at negative infinity, and then it's going to go up. Well, how high does it go up? Well, it goes up to our horizontal asymptote, and it's not going to cross it, because if it's going to cross it, it'd have to do like right in the middle. It doesn't. So it's just going to go up to that y equals 7. So our range is it goes down forever, and it goes up to the horizontal asymptote of 7. Then where it gets to 7, it's close to it. Now, the one thing you have to be careful of with the range is notice these graphs, when it split at the the vertical asymptote, they both went in the same direction. If they went in opposite directions, like one went up and one went down, we'd have a situation sort of like the domain, where so it'd be like if that had been the case where they went in opposite directions, then we would have had to have another. It would have been everything except 7. If that graph had split. But since both of them went down, that just means we were just from negative infinity to 7, so we didn't need the extra part. But that's we split the domain a few times. This is the first time this semester. This is the only thing where we've ever split the range. So it doesn't always happen, but just watch out for it. Okay, the vertical asymptote. Well, we already know that's x equals 0. Whereas the horizontal asymptote, there is we're never going to do anything with 2 horizontal asymptotes, so you should never answer B. Right? There is one horizontal asymptote, so y equals 7. Because notice that we did this part of it first, because when you're doing rational functions, everything kind of flows from those horizontal vertical asymptotes. Right? Where are the oblique asymptotes? Well, there was a horizontal, as long as since there is a horizontal, there is no oblique. It's either there's no horizontal asymptote and then there is oblique, or here's the horizontal and there's not. All right. Same idea, except now they don't talk about the asymptote or the graphing. All right. So, where is the vertical asymptote? Well, set that bottom equals 0. That's going to be at negative 19. The horizontal asymptote degrees are the same. So we're going to do 13 divided by 1. So it'd be y equals 13. Remember, if this had been flipped, or sorry, if this had been like, let's say, x squared on the bottom, then we'd have degree 1 over degree 2. So the degree of the bottom would have been larger. So then it would have been at y equals 0. Now, since there is a horizontal, there is no oblique. Yeah, really, if you're answering that there is an oblique, it would make me kind of wonder if you did all the homework in this section, because we never actually did anything with oblique other than recognize that there either is one or there isn't. We didn't talk about like what it is, like how to find it. That's one of those things that if we had another month in the class, we would have covered that as part of what we covered. All right, and now this is one where it's all thrown together again. Okay, domain and range of the function. Well, notice that they give us the function. So let's practice this again. So the domain is left to right. Notice that it splits right here at, what is that 2 or is that 1? So that's counting by 1. So it splits right there at 1. So the domain is not 1. So it's from negative infinity to 1. And then union 1 to positive infinity. Now the range of the function, low to high, this is that case I was talking about earlier. So if you go low to high, it goes down to negative infinity, comes up to this line, and then we kind of have to like lift our pencil and then draw this piece. So what's the range of this piece? That's from negative infinity. And what is that? 1, 2, 3. It looks like that's y equals 3. So the range of the lower half is negative infinity to 3. Not 43, just 3. And then we got another piece, so we need to do union. And then the range of this piece is 3 to infinity. We can have split ranges just like we have split domains. Okay, find the intercepts. Okay, well, this one's nice because the x and the y, the only place it crosses the x-axis is right there at 0, 0. The only place it crosses the y-axis is right there at 0, 0. So this one has 1. Let's see, it says type as an ordered pair. Again, read the instructions. So that way you know how to type it. If this had been moved to the left or right, then we'd have different answers, right? Just here, it's look at the graph. Where does it cross the x-axis? Where does it cross the y-axis? Put them as points. Put commas between them. If it never crossed, like if this had been at 0, 0 and moved down, then it never would have crossed either way. So it is possible to get no intercepts. Okay. C, find the horizontal asymptotes, if any. Well, there's definitely a horizontal asymptote. It's right there at 3. That's why we had those 3's up there in the range, because that's at y equals 3. Sorry, yeah, y equals 3. Don't forget the y equals. It is a horizontal line. Okay, find the vertical asymptotes. Well, that's where we divided by 0, where the graph splits. That was right there at x equals 1. And there's only one split in the graph, so we don't need to do the 2. Don't forget your x equals, because it is a vertical line. For the oblique, well, there was a horizontal, so there is no oblique. And to be an oblique, it would have to be like that horizontal line would be slanted. All right, same idea. All right, now, so this last one, this is a little bit better transformation. All right, so we got -2 over x minus 1. Okay, so when I think of the transformation, so here the transformation is, that x minus 1, that's horizontal, so that moves it right 1. Now this -2, even though it's in the fraction, it's not down here with the x. So that minus is actually a vertical flip. They could have easily put the negative out front. Okay, and now but it's not an up or down. So if I wanted to move it down 2, I'd have to go outside the fraction and then say -2. So this one has been moved right 1 and it has a vertical flip. Okay, so on the right ones, it's either B or D. Okay. And so how do you know which one it is? Well, this is the classic 1 over x is this shape. So that's not been flipped. It's B. And what do you do if you're not for sure? Okay, because again, the transformation stuff with the rational functions is a bit funky at times. Don't forget that you can, do Desmos. Okay. Now, where you have to be careful is you really want these as a fraction. If you don't put them as a fraction, then your order of operations stuff's going to get messy. The way you do a fraction is just do the backward slash, like right next to the shift. And so it was -2 on top, x minus 1 on bottom. Otherwise, the way you'd have to do this would be -2, but like put the top and bottom in parentheses. So -2 in parentheses, divide by, now it's not set up, divide by, put as a fraction, so it's still helping. But if it didn't set up as a fraction, You'd have to have every, top in its own set of parentheses, bottom in its own set of parentheses. But this is nice because it's recognizing that, if it's a fraction, it knows it means there's parentheses top and bottom. Okay. So, back to the question was, I wasn't for sure, like if it was B or D. Well, here you go. So that is what it's supposed to look like. And so then when you go back to MATLAB, it's clearly B and not D. Right? Domain, well, where do we divide by 0? Where's the vertical asymptote? Right there at 1. So we don't want 1 because that's where we divide by 0. So how do we say it's everything except 1? It is negative infinity, comma 1 with parentheses, union 1 to infinity. So the domain is all real numbers except 1. The range, if you look at this graph, since it's split like this, do the range of the bottom, do the range of the top. Well, the range of the bottom is negative infinity up to the horizontal asymptote, which is at 0. And if you're not for sure, again, on the Desmos graphing part, you can, since it's a bigger graph, you can definitely see it gets horizontal right there at y equals 0. So that means the range, so the range of the bottom half is negative infinity up to 0, not including 0. And then it starts over the range of the top half, starts at 0, goes up to positive infinity. Okay, well, where are the vertical asymptotes? I feel like we've already answered that because we answered up here in the domain that x is not 1. So the vertical asymptote is x equals 1. That's where you divide by 0. Horizontal asymptote, well, from the graph, it looks like y equals 0. And from here, from the function, degree of the top is 0, degree of the bottom is 1. So the degree of the bottom is larger. So therefore, it's at y equals 0. And since there is a horizontal, there is no oblique. Okay. All right, so this one, the full review here is only 24 questions because they're real, but it's still fairly long because you have a lot of these multi-step questions, and that's exactly what your test is going to look like. All right, so hopefully this helped. I would definitely, hopefully by now you've learned to use your quizzes, take them multiple times. I highly recommend that at least once you take that mini review, just like a test. Give yourself like 30 minutes. Don't look at any notes. Don't look at anything else other than maybe the graphing app, and just go through and see what you can get that way, and then that helps you focus your study. All right. Well, as always, if you have any questions, email me. Have a good day.